Yeah, what we're going to be talking about today is going to be about how GANs has really changed the entire dynamics and how it has changed the entire neural network, AI, and machine learning world. So let's just set up some things. Like I'll just give you a rough idea about what I'm going to do. So I'll be talking about the topics that were just mentioned for, say, about a 35 minutes session. And then what we'll do is we'll take up all your Q&A questions that you have. So whatever is coming to your mind or something that you would want to ask me could be put down on the Q&A session that you can see right below on your panel or right above wherever it is. So feel free to ask any kind of questions. If you're not able to understand the technical aspects of it, please to ask. If you want to ask anything about all and about neural networks, deep learning, data science, AI, feel free to ask any kind of questions that you would want to ask. So yes, let's begin with what is really happening in the world today. So the agenda is already something that has been mentioned. That is, we'll cover these topics majorly. That is, what are GANs? What are the different applications of GANs majorly? Then where all you can really use it, and what kind of architecture does it follow? So I do not want to make it a very tech-heavy session, but at least I would really want to focus on the fact that how its architecture is different from our conventional networks. So since we've all been seeing a lot of applications all around us, right? Like when we talk about any kind of deep learning application today, any kind of a app, like any kind of a service that you use today, be it say Google, be it say like Amazon, be it say AWS cloud, whatever you use today, you use your phones which have these personal assistants, say your Google personal assistant, or say for Apple you have Siri. All of these services have some or the other kind of amalgamation of some deep learning service that you can see in a way. So if I have to really talk about a very basic example, right, I would start with Alexa, since most of us would have, really relate to it and would have seen it at some place or the other. So the way Alexa is able to, answer your queries, you might talk about a certain thing in not a very formal way, but in a very informal way, and you just may ask Alexa to put on a certain song. It is able to do so very quickly, and it's able to even respond with a good enough answer. Now, what are these characteristics of? These are characteristics of smart systems, right, which have been built today, which are highly driven by AI. So the way our human brain functions and is able to answer any query and is able to understand any kind of a concept. In a similar way, what we have tried to do is we've tried to put that kind of power into machines so that they are able to think in the same fashion as we humans are able to. So that what will happen is it will reduce our manual efforts in one way. Number one is that only, that is reduction of manual efforts. Number two, we'll be able to get more work done with more hands, right? So whenever you have more number of participants, the task becomes more easier to solve and more faster. So we'll even cut down on the turnaround time for any task. So AI is really helping us in majorly these two reasons in a way. So all of these systems that we just spoke about, like Alexa, Siri, or even Google, the way it is so smart these days, it has some of the other kind of AI or neural network embedded into it. So let's get a bit more specific about the topic. That is, we are talking about how the entire ecosystem has changed. Like earlier, it was more focused on using machine learning algorithms. And by using very simple algorithms, we were able to achieve tasks. But now with the shift from 2000, 2004 onwards, like after Google, Facebook, Twitter, all of this has come into picture, we are generating a very large amount of data, right? So since we are generating a large amount of data, we would also want to utilize it in the best way so that we could get insights from it, so that we could drive our performance and revenue behind, right? So since this entire change has happened and we are using a lot more powerful processing techniques. So for those of you who might have, heard about maybe deep learning or neural networks in a very early stage of your career or wherever, you would not be aware about the fact that it was not implementable earlier because we did not have the processing power for it. But now today, as processing power is made available to us and as hardware has become cheaper over time, we are able to really utilize these technologies, utilize these algorithms in the best way possible to get maximum output out of whatever data we have, right? So since now we see that shift, we know that a lot of neural networks are being used in our day-to-day life everywhere, all around you. Now, if you look at your Android phone, like, or your Apple phone, whatever the case may be, you see that it can do so much more than it was able to do earlier. So it is so smart that it is able to tell you that, okay, this is the time at which, there could be a recommendation around it that, okay, this is the time and this is what you need to be doing as an activity around it. Now, if you are at a certain place, maps will give you a recommendation that, okay, this is something that you could visit. Now, all of this is possible due to AI, due to deep learning, due to neural networks, right? So that's exactly the point that we are going to be talking about as to what neural networks are and how it's useful, and majorly how the shift from just discriminative models to generative models has taken place. So what you see on this slide right now over here is deep learning in one slide. So all of you who would, really know about neural networks would have heard about three different networks which have been mentioned here, which is um, fully connected feed-forward network, convolutional neural network, and recurrent neural network. These are very common terminologies in the neural network world. So here, convolutional neural network is used specifically for images where images are visualized as matrices. RNNs or recurrent neural networks are used for continuous data or for string or characters majorly. The fully connected feed-forward network can be used for any typical tabular data problem. So these are the networks which you would have heard of and which you might have implemented and worked with even in the industry. So these different networks can take different kinds of inputs, like the X is your input and Y is your output. And there is a certain network in place over here, right? And there'll be some functions which are applied over here so that you are able to get this Y kind of an output, correct? So here you see that you give an input to it, which could be anything, which could be normal tabular data, could be numerals, could be texts over here on the left hand side in as X, could be speech, could be video, could be anything of that kind, right? And the Y would be obviously dependent on what you give X as an input. So you are trying to achieve a certain objective with the help of this X input that you provide, right? And there'll be some function which will be applied over here. And this is a typical setting of a deep learning network, right? But now when you talk about moving ahead, so since our topic for today is more about GANs, which is an abbreviation for generative adversarial networks. So they are more of a generative model. So if you see, if we talk about any typical application of any CNN network, we might have come across something like distinguishing between two different images, like whether the image is of a cat or whether the image is of a dog. So here the point is that what will happen is that you want to distinguish, right? That or discriminate. That's just a synonym for it. That is whether that image is of a dog or a cat. A very, very common example, something that you learn when you're starting with CNNs. So that's a discriminative kind of a model. Now, what we are going to be talking about is generative models. So GANs are a form of generative model. So GANs do not just help you into like the distinguishing factors, but they are able to generate new data instances. So whenever you want to generate something new on the data side, you would go towards generative models. Now these generative models capture the joint probability or just the single probability of an instance if there are no labels. So usually generative models are working on capturing the probability values. or capturing the joint probability with respect to certain instances. Now, for an example, we can take a factor that models that predict the next word in a sequence, like say, a relevant example to give over here would be about Gmail. So if you start typing a new email these days, what happens is that you might just type in 2-3 words and you will get some of the other suggestion for the next character or the next words which could fit into the sequence, right? So what is that? That is generative model because it's generating text, right? So it is going to be assigning some probability to a sequence of words which are coming in sequence. So it is a generative model, but it is a much more simpler version than the GANs that we are going to be talking about. So that's just one, you can talk about it as a variation or an example of what generative models are for you to understand the intuition behind. Now, this is one, okay, I see someone's raised their hand. I think I'll just take that question up at the end in the Q&A session so that we can continue with the flow with respect to the time that we have. Okay, so here what you see is creation. Okay, so creation is more about anime generation. So whatever you see in terms of anime today, they are often generated with the help of GANs. Now, anime face generation is something that can be achieved with the help of a GAN, which is a generative adversarial network. Okay. Now here, if you see, this is a specific kind of a GAN, which is a DC GAN. And you can know about it and read about it a lot more in detail if you are really interested towards it. These are more like a cyclic GAN variety. So there are different varieties also which are there in GANs. But this is just one of the examples that you see where you can generate faces for anime with the help of these GAN networks which you have. Okay, so let's move on and try to understand how the network would really be structured, because it is going to be different from your typical CNN or typical RNN network. So here, of course, the vector is going to be an input, which you see on the left-hand side over here. And there'll be a generator as your middle section, which is nothing but a neural network or a function in the similar fashion that you would assume your network to look, or your neural network to look like. And then at the end, as an output for a GAN, you'll always have an image, which would be more representative, just like a matrix, right? So here, the generator is going to be generating the image for you on the basis of the input that it gets. Now, this input could be anything. It's not necessary that the input or that is given to a GAN is always an image. Could be anything. So here now, if you see this vector, which is passed at the left-hand side, let me just a pointer so that you all know what I'm really talking about. So this vector that you see on the left hand side, this is passed in as an input to the generator, and each input value that you provide or the vector that you provide is going to be helping the generator to understand about different characteristics. So over here, if you see the 3 value, the topmost value is going to tell the generator that it's talking about longer hair. Okay. Next, what you can see over here is 2.4 is given, which is more representative of a factor that it is blue hair, right? Then what you have next is 3.5, which is more representative of the factor, which is open mouth. So this is nothing but how it's learning about the different features and how it's going to be able to understand how a generator is really able to learn and it's able to structure things, right? Let me move ahead. Yeah. So there are 2 parts to a GAN usually. One is a generator and the second part is a discriminator. They both together form the architecture, or what you can say is a fundamental unit of any GANs. So here the image is passed on the left-hand side as an input, and you have the discriminator in the middle, which is again a neural network or a function, and it will give you a certain output. Now here the output of the generator is always an image, but the output of a discriminator will be a scalar value. So larger the value would mean a real image, and smaller the value would mean that it's a fake. Okay. So say the value that you will get would be either, it will be between 0 and 1. So 1 would mean that it's a real image and 0 would mean that it's a fake image. Now you must be wondering what a real and fake image is over here. So the discriminator, as the name suggests, is supposed to discriminate between two different images. So once the image has been generated by the generator, the image is next passed to the discriminator, who will decide whether the image is real or fake. So this is more like a classification neural network or a CNN network, which is going to help you to do classification. So that will decide whether the image is real or fake, so that it is able to get the best outputs possible in front of you when it's trying to give you the outputs from your GAN network. So if you see over here, this discriminator value is 1.0, which means that it's a real image. Now, if you see below, the image is pretty blurry and it's not something that you can really recognize. So the value is 0.1, which means it's close to fake. And over here on the right hand side, you see that the discriminator value is 1.0, which means it's closer to real. So this is the kind of intuition that we have when we are trying to understand about the discriminator part of GANs. Now, how the flow of a typical GAN system works is as follows. Now, if you see, this is a butterfly. Okay. And this is the image that has been given as an input. Now, the generator will try to understand the patterns and see what all it can really absorb from the surroundings, the environment, and then decide and come up with an image which it can create. So this is an intermediate image which is created, and say these are the veins which are created for maybe the base or the background on which the butterfly must be perched. So this is how the model actually gradually learns, and the generator is able to identify patterns and is able to create new images depending on the task that is there at hand. Now, what the discriminator does is that it tries to understand what are the characteristics of a butterfly and what are not, so that it can distinguish between real and fake. So right now, the image that we are considering is of a butterfly. So hence, these are the patterns that we are talking about. So here you can see that butterflies are not brown in color. So this particular image cannot be a butterfly. The middle image does not have veins like this particular leaf, or the way you have veins on the butterfly's wings. So butterflies do not have veins. So this is how it tries to identify each and every reason, and that's how the discriminator is able to distinguish whether the image is real or fake. So this is the intuition, or how you can really understand the architecture of how GAN really works. Okay. Now, the term adversarial comes into picture because there are different variations which will be created as and when the GAN is trying to learn, and as and when the GAN proceeds throughout its entire training cycle. So if you see over here, you have V1, okay, neural network generator V1. So version 1 is generating a very blurred image, which does not have a lot of, what you can say as clarity and feature enhancement over here, correct? So that is what is the version 1. Now, as you train further, you know that neural networks learn over time. That is something which is very, very clear for all of us, right? So you can see V2. V2 is more about how the intermediate images are generated, where you can see that certain patterns and features have been identified, correct? So that's more about your discriminator version V2. Then you have discriminator version V3, where you have the neural network generator V3, which is able to generate it in a much more better way, and the images are generated way more clearly. So the real images are way more closer to your V3 in comparison to your V1 and V2, because there's not much clarity in terms of how the model has been able to learn patterns or features, right? Okay. Now, you can assume that the generator is more like a student and discriminator is a teacher. So as and when you progress throughout your career in school or in college or wherever, you tend to perform certain actions and the teacher validates it, right? So you are taught about certain things, and on the basis of which the teacher is going to validate your questions, right? Like whether the actions are right and whether the questions that you're asking are on the right track or no. So that's exactly what we are doing as a part of the GAN also, since there are two different components to it, generator and discriminator. Generator will learn. Discriminator will try to analyze it and try to judge it, whether it's right or wrong. So if you see over here in generator V1, discriminator V1 will say no eyes, can't see anything, not able to distinguish, right? Then in generator V2, what we have is no mouth, cannot really identify. So the characteristics are not clearly visible. So these are some of the things which the discriminator does as a part of its job. So this is how, iteratively the generator learns and tends to build models which are able to distinguish all the features and characteristics from any image. And the discriminator keeps on judging it, keeps on criticizing it, and tries to improve it in the best way possible so that it's able to distinguish the real images. Now, when we talk about any machine learning system, we are trying to find a function f, right? Where y is your variable that you're trying to predict, that is your dependent variable, and x is your independent set of variables. So in the case of regression algorithms, there'll be a scalar, which is an output. In case of classification, you'll have like maybe a one-hot vector or one of the classes which you would want to predict. Then you have structured learning or prediction, where you might, want to output a certain sequence, a matrix, a graph, a tree. So output will be composed of like different components with whatever kind of dependency we have. This is what we've seen when we have some kind of structured learning or supervised learning, right? A normal structure that we tend to see. Now the output sequence is also such that you're finding such a function f with where x is an input and y is your output, right? So say in a machine translation system, X is given in a certain language, so this is Chinese, and this is the sentence of language 1, okay? And in Y, what you're really getting is the translated language. That is okay, whatever characters are mentioned here, you get the translated language. So you want to translate that Chinese sentence into English, so that's exactly what you're doing. So here you have machine learning and having it deep and structured. So that is your sentence of language 2. Next kind of application that you might see. So this is something which you see in Google Translate, right? Something that we use on a day-to-day basis when we do not understand different kinds of languages. Next is speech recognition. Now, when we talk about speech, there is a lot of transcription which is required if the language is something that we are not aware of. And often we would want it to be transcribed because we might use those transcriptions for further analysis. So in this kind of a case also, you see that the speech sequence would be your input and the kind of output that you have would be the transcribed output, right? In a chatbot, you ask a certain question. What a user says is like, say, how are you? And the chatbot replies saying, I am fine. That is the response of the machine. So this is how you can see different kinds of applications which are there in any neural network system or whatever you might have seen. Now, how does your GANs really help you in this particular case? So if you see this particular example where an image to image is really being generated. So if you look at your older images, your childhood images where your pictures are captured by using a camera roll, they can be made better and more realistic and look more real with the help of GANs. Now, how does this work is this is your X, like an input, which has more like a design, or you can say a layout, a blueprint, and Y is your finished output. So it's able to generate this, understand patterns, able to generate this with the help of a GAN net. It can even help to colorize your images. So if you recall, we had a lot of content which was in black and white earlier. But nowadays, if you really see, everything is in color. So they have used technology to really help do that colorization for your black and white images and get it to the standards in which it is currently available. Like if you picturize something right now, it is in a color format, right? But earlier, the things would be in black and white, and then they can be converted now with the help of GANs. So you can do a lot of things in terms of enhancement, image generation with the help of GANs. Next, what you see is a text to image. So say you just had a certain sentence in mind and you would want, what you would really want is a visual representation of the sentence that you just had in mind. often when we are reading books, right, novels, we tend to visualize what the scene is actually talking about because you're just reading about it, and the reading, like the words itself, has so much depth that you're able to visualize it. Now say you really want to visualize it on screen and have like a dummy representation of what kind of text you want to present. So here, like this is a sentence: this white and yellow flower have thin white petals and a round yellow stem, mostly something of stem over here. So here, what kind of output is displayed is this kind of a flower. So this kind of an application can be totally developed with the help of a GAN. So GAN is going to be able to learn what these words are really representing, and it will be able to come up with a picture which is going to be representing exactly what is expected out of that sentence. Now, the point is that it might not be exactly what you were visualizing, because the way you would, really expect it to be could be different, right? But what really happens is that it is able to understand the individual components and depict a scenery in front of you by using the data, by using the entire network of generator as well as discriminator. So this is the kind of output which is generated out of GANs. And these are very common applications that you would see, which could be achieved with the help of GAN. Now, coming to those two different blocks that we are talking about, that is generator and discriminator. Generator is used to learn to generate the object at the component level. So it will determine the features, it will try to understand how the layout is structured, and then after which it will send it to the discriminator. The discriminator will evaluate the whole object and then find the best one, that is which one is very much close to the real image. That is what it will give as an output. So more like a bottom-up approach and a top-down approach, where you generate, then pass to the discriminator, and then the discriminator will decide whether this particular image qualifies to go to the next level or qualify to go to the user or not. Okay. So both of these components have their own respective losses, which is called as the generator loss as well as the discriminator loss. And you have a combined loss, which is called as the dice loss, which is used for training this particular models. Now, yeah, in terms of image generation, since we were saying that it is able to generate also, right? So there is even a way to control what it is able to generate. So till now, what we've been talking about is that the model will learn about the features, and then it will subsequently generate some kind of images. Now it will generate faces, it will generate different kinds of things depending on the application that you're working. Now the point is that it can even control what it's generating, which is called as conditional GANs. There are different varieties of GANs which are there and available a lot more in detail. So those all things could really be used and could be worked upon depending on the kind of use case that you're trying to solve. Now over here, when we talk about image generation, like the anime face generation task that we have been talking about, it will take certain vector values, and on the basis of which it will generate these anime faces, which would be new characters which could be generated. So today, if you see, the anime world is also so large, like in terms of animation, it is a very big world. Now, how are they really coming up with unique faces and unique characters? They are using some kind of GAN technology to really come up with new characters. How would they look like and everything? So it's not just dependent on how you would design the characters, but then it goes way beyond where technology itself is able to generate such faces and such characters. Now, sentence generation. So there would be certain kind of input which is passed to it, and you would want to generate sentences for it. Right? Okay, this is what is expected. That how are you? Good morning, afternoon. Typical conversations that we would have. That is something that we would want the GANs to generate. That is also something that is quite possible to achieve. Right? Now, on. So you must be wondering what the difference is, right, between generator and discriminator. We said that the generator is going to generate the things, and discriminator will discriminate and decide whether it's real or fake. So the generator is easy to generate because it's going to use some CNN backbone architectures, and it will come up with a a certain network which is able to actually identify the features, and it's able to generate a certain output. Now, there are certain cons associated with it. That is, it will imitate the appearance of whatever data points that you give. So you gave it certain faces data and it will imitate that. And it will be hard to learn between the correlations between the components, right? Since it's generating, it will be very difficult for it to identify the correlation component. Now, discriminator is very smart. It tries to ensure that the GAN is able to achieve the diverse factor also. That is, diversity is also something that's achieved. So it considers the bigger picture. And what happens is often generation is not feasible, right? When your model is very deep, it will not be feasible. And if you want to do some negative sampling, that is your negative cases that you want to test, it becomes difficult with respect to the discriminator, because the discriminator is going to be distinguishing between your real and fake images, right? So when it's doing that, it will have a certain limitation in the sense of generating these fake images. How much will it be able to generate? Because the real images are something that will be checked when the model is run through the discriminator, right? So these are the major differences that you have in a generator and discriminator network. What will happen is, for a generator, the output will be more like a matrix, a certain n by n, m into n value. And discriminator, it will be more like a classification problem. And since it's real and fake, two classes, 1 or 0 would be the output layer of your discriminator. Now, when we talk about how it really works in terms of training this particular architecture, you will have to start with randomly initializing your generator and as well as your discriminator. Most of our neural networks work today in this fashion only, right? Where we will sample some real objects. So we take in some data and we feed it to the model, which is all your ones. And then we generate some fake data or fake objects with the help of this generator, right? Then this generator is going to further on pass this image to your discriminator, which will fix it, that whether this image is real or fake, it will give as an output. And it will update the discriminator loss. Here it's going to be updating your generator loss. So that's how it works more on the surface level. When you try to understand it in detail in terms of the mathematical aspects of it, you will get more clarity on how it's using these G losses, D losses along with your combined factor, which is more like a dice loss. That's exactly what it will, right? So that's how this particular architecture works. So learning discriminator, learning generator. So both the networks are simultaneously working, that it is going to work on generation. Once it is generated, it will pass it to the discriminator. And after which the generator loss is going to be updated depending on what the kind of pattern and what kind of output it is able to generate. Now, there are some benefits of GANs, which we have been really talking about. Now, if we pick up different kinds of applications, we look about that when we talk about specific industries and specific applications. From the discriminator's point of view, using the generator to generate negative samples is a bit of a like a regular thing, right? Because the generator is going to be generating some images. Now, it will use the argmax function. I am sure you would have heard about maximizing the value of the function f of x, right? Or which is d of x over here, which is the discriminator value. That is what we want to really maximize. So we will use some negative samples for testing it. So from generator's point of view, it will be involved in generating the component, like generating the object component by component. But the overall picture that it will get is through the discriminator when it is looking at the global scenario, that is the entire image and that is the entire perspective. That's when it will understand more about how the discriminator is working, and that's how the credibility of the generator is also affected. Now, that was more about what is GANs, since that is a very important aspect of what GANs are. Now, talking about how GANs are really used in terms of applications in different kinds of industries. So the first kind of an application that you can really see over here is text to image. So say you have a certain text of data, a pitcher is about to throw the ball to the batter. Okay. This is the sentence or the caption. This is caption generation. So caption generation can be used at a lot of places. It can be used in social media. It can be used in as a part of different kinds of videos, wherever you would want to, generate videos on the basis of these text values, right? So here you can see that this is a baseball game, and that's what has been generated over here in terms of images. A group of people on skis stand in the snow. So people are there on their skis and standing in the snowy region. So that's what it is able to generate. A man in a wetsuit riding a surfboard on a wave. So it has been able to picturize that, learn that, and come up with this particular image. So you must be wondering that how is it automatically able to generate some images? So for training a particular GAN, you will have to give it certain images as well as texts. Right? You will give certain images which are there maybe of objects or which are there about scenery, like say snowy region, something about say like flowers. You will give it different flowers. You give different human beings. That's just one way for the model to really learn what is being mapped where in terms of scenery and in terms of the people or the objects involved. Now, video generation. So you often see a lot of trailers and teasers now coming in, right? Where they are very highly edited videos. So if you see, often there are sceneries which are created, which are not actually existing on the earth. Okay. What will happen is that the object is there somewhere, but the background and the entire action around it is something that is generated, computer generated. So that is what is exactly what is called as video generation. So there'll be a target and you give it to the generator that, okay, this is what I want to really create in terms of the video. I have done that. Now it will go to the discriminator. The discriminator will check whether the frame that was generated for the video, whether it's real or generated, and it will able to optimize that on the basis of the model that it has for discrimination. So video generation is also a very good example. Now, if I have to give a very realistic example, then Brahmastra is one of the first movies which was having the latest VR and augmented reality and all kinds of deep learning into place. So they have used some kind of video generation technique for certain scenes because those places do not really exist on the earth. They are more likely synthetically generated. So synthetic generation would involve some or the other usage of GANs in terms of different tools and technologies which are used in the film industry, in the media world. Speech enhancement. Now, speech enhancement, as you already know that we may often have to record some kind of speech for a video or speech for a particular session. Now, there are a lot of noisy components which are present as a part of our speech, right? Because you might just be recording it at home and there is background noise, there's data coming in from your neighborhood, wherever for that matter. So that's more like a typical deep learning approach where, you will just clean it up. Noise cancellation is something that it's referred to often. Now, if you want to modify the voice, say you have a certain sentence, okay, or a certain paragraph, and you would want it not to be said in, say, not in my voice, in someone else's voice. You want a synthetically generated voice. Something like your customer cares, which are highly automated, right? So wherever your customer care speech is coming into picture, it is enhanced voice, it is generated voice. That is something that you can do with the help of GANs. So the cleanliness part is something that can be achieved with the help of a deep learning model. But when it comes to synthetically generating voice or generating any kind of music or anything, here GANs come into picture, where it's going to modify the voice and try to ensure that it's able to generate the right kind of things that it's really looking for. So this kind of application you will see in the advertising and the media industry, where noise is first of all cancelled, and the voice is often synthetically generated. So you might feel that this voice that is generated is more like what you can say is using a, a certain person's voice, but in an enhanced manner. So that it sounds more better. So that kind of application is also existing where speech enhancement is done. Now, the theory is something that you have understood in a good way, that if it's a high probability, it goes to the discriminator, that the data that we want to generate has more of a distribution where it has a data in the X distribution. So if it has a high probability that the discriminator is able to give it as a value, then it is a real image. Else, if it's a low probability image, then it's a fake image, right? A generator G is the network, and the network defines your probability distribution. So the data that you give it should follow some kind of normal distribution, so that the distribution that is calculated or computed as a part of your network is something that is going to be very difficult to compute, because generator can go either ways. It can generate a completely black image, it can generate a completely white image, it can generate any kind of image, because the matrix that is there in hand for it to generate is open to any kind of value to be taken. So that's why we have these different kinds of losses that I was mentioning, right? That you have this discriminator loss and a generator loss. So there is a divergence measure which is taken into consideration. It's a bit more technical. So until and unless you understand the complete network working of your generator or discriminators, don't lean towards it. Just try to understand only the losses, and after which you can really go towards this divergence part, where it is going to minimize your divergence measure, and it's the discriminator, which is your binary classifier, is going to evaluate this particular divergence measure, which is going to see how two images are far or how two images are really close in the simplest ways. So we have to design the discriminator network in such a way that it's able to evaluate this kind of a divergence which we would want to measure. Now, this is a typical architecture, as I have really mentioned, that if you really want to generate some digits on its own, right, digit images, like the most common MNIST data set that you have, and if you want to generate new images with the help of a GAN network, you will have your database which has some real samples, right? Now, the generator is going to be generating certain fake samples. The discriminator will identify or discriminate between these two set of samples, and you will get an image which is either on the real side or on the fake side, either of the categories. And on the basis of which you have the loss calculated, which is a backpropagation error, which is going to be updating your discriminator weights, which will in turn update your generator weights, and on the basis of which the further training and the further images are going to be really working. So this is a typical architecture and it stays the same. Now, the generator and the discriminator networks will have your CNN network layers. So it might have convolution layers, it might have pooling layers, it might have global average pooling, could be anything, your batch normalization, all the typical layers that you would see in your normal CNN network is all that you would see even here. So that's how the architecture is largely. When we talk about how it is useful in different industries, so 2-3 things that I would want to point out, that is, it is used a lot in the medical field as well, like to generate different kinds of images. Especially it's used in segmentation of these reports that you do, right? You might do brain scans, you might do certain organ scans. So it is able to, like, the GANs are able to really help you to do segmentation. It helps you to generate certain images which might be, present in a very low scale when you really use the reports, but it will help you to amplify and generate the image and actually project what the tumor would be in terms of brain tumors, could be in terms of cancer particles. Any of those kind of things can be really enhanced with the help of GANs, which are used in the medicine industry. Then we've already spoken about how GANs can be very useful in advertising media. Now they can shoot a particular ad at a particular place, but only where the object is taken into consideration. The background and the entire movement that happens beyond can be generated using GANs. I can give you a very realistic example where you have a certain car, right? Now, if you want to generate its shadow, you can do so with the help of GANs. So if you have a certain image, which has little objects, maybe say balls, maybe say vases or anything, chair, table, any still object, it can generate shadows for it. Like a very realistic example so that you can relate to what GANs are able to really do and how it can be really utilized in the best way possible. So say I want to,
Excuse me, Ekta.
yeah.
Yeah, this is a reminder that it's around, we have 10 minutes left.
Yeah, it's just the end. I am opening it for
Yeah.
Q&A. Okay, so what I was talking about was that it can really generate certain shadows, which can be very useful. Now, if you think about you selling certain items, like you want to sell your own products on a website. Now, you do not have to go to a photo studio and really shoot it. You can click a picture of it with a very normal background and then generate backgrounds around it, generate the movement around it, which can save a lot of cost because you will not have to really go to actual locations and shoot it, but you will be able to get those kind of outputs with the help of technology. So yeah, that brings us to an end with my session. We'll open it for Q&A. You all can ask any questions that you would want to, but before that, I'll just answer the questions which are there on chat and which people have answered. So Mayank is asking, what are the Python libraries for GAN in different scenarios? So as we've really mentioned, right, that we want to develop different kinds of applications. So the applications will have a specific kind of a GAN architecture around. So there are different kinds of Git repositories which have these GANs which are already implemented. Okay, so there are GitHub repos for cycle GANs, there are GitHub repos for face generation, there are GitHub repos for medical tumor segmentation. There are way too many different repos which are existing, which you can use for your generation. There is the libraries are, see, the network is same as CNN. So it will either be using TensorFlow or PyTorch. So there's no change in terms of the backend which is being used. So there are different implementations which are there on GitHub which you can refer to. There are no specific libraries for GAN. I hope that answers your question. Shalini is asking, are you going to go in the math of generator and discriminator? Okay. So since this was a very introductory session for me to go into the math part of it, would just become too overwhelming. That's why I have just covered it on the very surface level where I'm just talking about the losses and where I'm just talking about the different ways in which the network is actually structured. So maybe if you're really interested in the math part of it and we have a lot more audience which is interested, we could do such a session where there would be the mathematical implementation and the focus around it. George Aguya is asking, are the discriminator parameters part of the input data or how are these generated in the GAN? So if we talk about the parameters for discriminator, they are generated by using the random values on like the weights by which you really initialize your discriminator, right? On the basis of which you have your network really being trained. So the parameters are not actually based on the input data, but the real images are going to come from your input data because that's where it's going to be comparing and it's able to like really generate images which are better than that. Dinesh is saying for video generation, which GAN model is used? So there are video GANs like video cycle GANs and video generation GANs, which have a lot of implementations on Git. You can check out GitHub for the different implementations around that. It would be really useful to check that instead of really looking at it from an article perspective. So you can really look at the implementations, try to implement it and maybe get more better insights around it. Can a GAN model generate a video piece from still pictures? Yeah, it can. So it's able to even generate motion. All of this is possible. Completely possible to do with the help of GANs. If we want to generate text to speech in my voice, which GAN model would be used for this? So first of all, there are Python libraries which are going to be enabling you to do that. That is text to speech. But the kind of GAN model is speech GANs. I can just share the link on the chat. The one which is going to be really useful at this particular point, I'll just put that particular implementation on the chat window before I drop this session. How exactly is generator is generating these blurry or noisy images? So the same way that you have image classification algorithms which are able to understand very small and very blurry features from your images, in a similar way the generator is working in the same fashion. So the first iteration is only identifying very few things. Madam, how can we do PantCam image to multiple ways using GAN? I am not sure about what PantCam image means. If you can elaborate, that would just help in understanding. Is there an example Python code with a GAN use case you can share and we can have? There are multiple articles present on Medium, towards data science, even on analytics Vidhya, which you can use, refer to for the Python code for GAN. So just type in for a simple GAN application and you should be able to get the codes right in front of you. Is there any AI app on web to try these models? AI app on web? No. So these models are going to be compute intensive. So you will have to train and try them on one of your mediums. That you either use your local, you use Collab, you use cloud, whatever you use, you can try that to train those models. Can you simplify how the backpropagation is different in GANs as compared to a CNN or FCN? Okay, so this is about diving into the math part of it. But I'll just tell you briefly that we handle just one loss at the end of a typical forward pass and a backward pass in a neural network, right? But in GANs, we have to modify both the discriminator loss as well as the generator loss. So that's where the formulas differ and that's how the math really differs into it. How to develop the skill to code the research paper in GAN, because it is overwhelming when we read these papers and it's very hard to implement from reading paper. Any suggestions? Okay, so for this, what you can really do is look at the different implementations of GANs which are there on GitHub. Try to have a look around that, how they have implemented, and after which you should really attempt it. Do not attempt it before looking at sample codes and without any experimentations. So look at sample implementations, then see how you can really modify them and how you can really incorporate your changes in that. As I'm doing AI tool using image data, it is a decision making, is object is capable for surgery or not? Okay, decision making object is capable for surgery or not. It is used along with different techniques. So it's used along with manual intervention. Since it is a medical scenario, it is highly important that you have safety in place. Can you suggest a few links to get knowledge about different types of GAN models? So I'll ensure that you get certain links around the GAN models to be sent across to you. Okay. How to develop the skill to code research paper? Okay, that is answered. Other versions of GANs with simplest implementation is it? So there are multiple versions of GANs which are existing on the internet. Too much to really explore. The easiest one is face generation. So the way you have anime face generation, in a similar way you have human face generation. So that's exactly how you could, really go about and use GANs. Okay, there are questions even on the chat window. How to develop? Okay, use to. Do we use CNN more in the case of this topic? Are there already types of computer software that are used to generate and discriminate? So CNN is the backbone. Okay, CNN is what is used to really define the network layers over here. It is not a substitute for GANs. It is used to create the GAN network, or majorly it is used to create your generator and discriminator models. How can we use GAN using this like health industry image data? There are a lot of applications in the medical field which you will come across where GANs are being utilized up to a very larger level. So it can be used for segmentation, it can be used for restructuring, it can be used for identification, it can be used for discrimination. There are a lot of applications in the medical field, which can be really utilized to get maximum benefit in terms of your applications that you're looking for in the medicine industry. So if you try to read a bit more about it on the research paper side or even on Google, you'll get a lot more information about it. Yes, I think, yeah, that's it on the question side. Over to you, Umesh.
Thanks a lot, Ekta. Personally, I want to know that is GAN also helpful in creating fakes and deepfake videos, which are nowadays a lot trending.
Yeah, it is utilized even for, so since you just mentioned deepfake videos, they are the revolutionary things which are actually driving revenue, driving a lot of performance, driving a lot of things in the industry. So the same kind of example that I was giving for media and advertising, you can generate videos with the object in place, or often the object also might not be required and the entire videos could be generated technically. So it saves a lot on the actual shooting perspective and everything, and it is able to generate videos which are quite much similar to your real videos. Thank you so much.